Welcome to Maths Made Easy. Today we are going to see third chapter in geometry, basic geometry. It's triangle. In last two lectures we have covered angles and line, polygon. Let's get started. Triangle. Triangle is a three-sided polygon. The symbol of triangle is like this cone, pyramid or whatever you say it. Sum of angle of a triangle is 180. We will be using this formula. N minus 2 times 180. For the triangle, n is equal to 3, that is 3 sides or 3 angle. 3 minus 2 is 1. 1 times 180 is equal to 180 degree. Therefore, the sum of angle of every triangle is 180 degree. If the value of two angles in a triangle is known, the third angle can be calculated by subtracting the sum of two known angle from 180 degree. It's very easy to understand. Let me demonstrate it. Let's say if this is a triangle, this is 30 degree and this is 40 degree, and this one we don't know. So 30 plus 40 is 70, 70 minus 180 is 110. Well, this is not the proper triangle to say it, but I just wanted you to get some idea about it. The length of one side of a triangle is always less than the sum of the other two sides. Very good point. The length of one side of a triangle is always less than the sum of the other two sides. In triangle, you add any two sides and that is going to be always bigger than the other side. Either it is either of the two sides, when you add, you will find it's bigger than the other side. In a triangle, the largest side is opposite to the largest angle and the smallest side is opposite to the smallest angle. And the middle length side is opposite to the middle angle. This is also very easy to understand. The angle, bigger the opposite side. Smaller the angle, smaller is the opposite side. Okay, there are types of angle. There are types of triangle. Equilateral triangle, isosceles triangle, scalene triangle, acute, obtuse and right. In equilateral triangle, all the sides are equal. All the angles are 60 degree, meaning all the angles are equal. Isosceles triangle, two of the side is going to be equal. Angles are also going to be equal. In scalene, all the three side and three angle is not going to be same. All are going to be different. Acute angle is all the angles less than 90 degree. If all the angles are less than 90 degree, it is called acute angle. Equilateral triangle is a kind of acute angle, acute triangle. Obtuse triangle is either one of the angle is more than 90 degree. Any of the one angle will be more than 90 degree. Like here, right angle triangle, one angle is equal to 90. So triangles are basically 6 type. 3 of them are based on their side and 3 of them are based on the angle. Based on side, equilateral, isosceles and scalene. Based on category, based on angle, is acute angle triangle, obtuse angle triangle and right angle triangle. In equilateral triangle, all the 3 sides have equal length and all the 3 angles have equal measurement. That I just told in the last slide. In an isosceles triangle, 2 sides have equal length and opposite sides, the 2 equal sides have equal measurement. In a scalene triangle, all the 3 sides have different length and all the 3 angles have different measurement. If one of the angle in triangle is right angle, that is 90, it is called right angle triangle. If all the angle in a triangle are smaller than 90, it is called acute angle triangle. And if any of one of the angle is more than 90, it is called obtuse angle triangle. In a right angle triangle, the opposite side to the right angle is called hypotenuse. In right angle triangle, the side which is opposite to 90 degree is called hypotenuse. In a right angle triangle, the square of the length of the hypotenuse is equal to the sum of the square of length of the legs. It's basically it is Pythagorean theorem. It means square of the hypotenuse is equal to square of the sum of the square of the other legs. Legs means other sides. This is called Pythagoras theorem, and this Pythagoras theorem is only applicable in right angle triangle. None of the other triangle entertain Pythagoras theorem, only right angle triangle. If the length of the legs are x and y and the length of the hypotenuse is z, the Pythagoras theorem can be written as x square plus y square is equal to z square. Okay, there are some important triangles also. Noteworthy right angle triangles are 30, 60, 90 degree and 45, 45, 90 right isosceles triangle. They are noteworthy because of their property. Okay, when the triangle is 30 degree, 60 degree and 90 degree, their sides are in ratio, and these are the ratios. Hypotenuse is 2x, then the side opposite to 30 degree will be half of it. If it is 2x, this is going to be only x. And the side opposite to 30 degree is root 3 times of the other side. Meaning to say that it is root 3 upon 2 times of hypotenuse. Like it was 2x, but it is root 3 upon 2. So we 2 get cancelled and we have left with root 3x. Similarly for 45, 45, 90, the sides are in the ratio of, let's say the hypotenuse is root 2 times x, then other sides are x and x. Okay, there is another noteworthy triangle. They are called triplets. The most common triplets that we see is 3, 4, 5. 3, 4 and 5. Their sides are very easy to determine. 3, 4, 5. 5, 12 and 13. 7, 24 and 25. And also note that their multiple of the ratio of this triangle is also a triplet. Triplet means basically the triangle whose sides, when Pythagoras theorem is applied, all the sides are perfect number, not in decimal. Like this, another is 4, 5, or let's say this is 4, 7. So the other will become something very weird number, maybe in decimal. They are not in decimal. That's why they are called triplets. And the ratio and the multiple of this, like for this one, 3, 4, 5, 6, 8 and 10 is also a triplet. 5, 12 and 13. 10, 24, 26 is also a triplet. In this case, 3, 4, 5. 9, 12 and 15 is also a triplet because I am multiplying them by 3. Two triangles are called concurrent triangle if, okay, what is the condition to be a concurrent triangle? Concurrent means same, copy. If the sides are same, all the angles are same, then the triangle are called concurrent triangle. All the three corresponding sides are equal and are called side, side, side. This is evidence. If all the sides are equal, with this evidence, side, 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 we can say that triangles are concurrent triangle. Two corresponding sides and the vertex angle are equal. This is evidence number 2, side, angle and side. If we see these two evidence, two of the sides are equal and one angle between the two sides are same, then we can say the triangles are concurrent with the evidence of side, angle, side, SAS. Sometimes it is also written as SSS test, SAS test, side, angle, side test. There is a third evidence, angle, angle, angle. If all the angles are same, then the triangles can be said concurrent based on the evidence of angle, angle, angle. That is AAA test. If all three pairs of corresponding angle in two triangle are equal to each other, the two triangles are similar triangle. Like we said in the previous slides, if angles are same but the sides are in ratio, in that case it is said to be a similar triangle. Two similar triangle can be created by drawing a parallel line to one of the side of triangle. Like this one, ACD is a triangle. In case I am drawing a line, this triangle is a similar triangle, triangle ACD, and the smaller triangle that you see is similar. Why? Because angles are same. Because this angle is similar to equal to this angle is equal to this, and this angle is equal to this. Triangle ADC is similar to triangle AEB because 3 corresponding angles are equal. So they are similar triangle with the evidence of angle AA test. If 2 corresponding angles of 2 triangles are equal, then the third angle is also equal. If 2 angles are equal, then third is automatically going to be equal. If 2 corresponding side of 2 right angle triangles are equal, the third corresponding side are also equal and the triangle are concurrent. In case the sides, if 2 sides are same of 2 different triangles, the third side is definitely going to be the same, and that kind of triangles are called concurrent triangle. This can be proven using a Pythagoras theorem. I hope you got value from this video. If you did, then please consider subscribing to my YouTube channel. Thank you very much. I will see you in the next one.